Hello and welcome to everyone to my channel. As we are going through our DSA playlist, today we will study about insertion sort. What is insertion sort? Just like any other sorting algorithms, we perform a shift operation. Unlike bubble sort, where we used to swap the numbers, here we perform shift operation uh, to find our resultant array, or let's say our sorted array, to get to a sorted array. Here in this process, we consider or take a key. First of all, we as and after taking that key, we place it in its rightful position in the array. In means Suppose if we consider 4, then 4 is already sorted. Suppose 4 we are taking, then 4 we are considering that 4 is the only element in the array, and we will place it in its correct position, right? So it is by default in its correct position if it is the only element in this array, right? We are considering a key and starting with 4. 4 is and if we consider that there is only one element 4, then it is already in its correct position. So no need to perform any operation for now. Okay, now the key moves to the second place, and now the key is at number 2, second position, and we are considering this as our key. So when we are considering 2 as our key, then what happens? Let's see. So now we need to perform the check to our left side. We will for now there are two elements only, 4 and 2. We will consider only those elements that are before our key, before our key, and our key is pointing at 2, and there are only two elements, 4 and 2 for now. So is it sorted? It's as we can see that 2 is smaller than 4, then 2 should come at the left position of 4, right? So what we will do, we will shift our whole of the array towards the right side, until and unless there is any smaller element present than 2, or this array is out of index, means it is already a zeroth element. So two conditions I have told. What? That we will keep on, sorry, we will shift the whole array right side of key until and unless there is a smaller element, is a smaller element than the key, or key is at zeroth index, basically the starting line of the array, right? So what I mean to say is that since 2 is smaller than 4, so we will shift 4 right side by one place. So if we do that, now here comes 4, and as it entered in the beginning, we will just do that. Now we will again perform the check that if there are present any elements that are smaller than 2 or not, and since there were only two elements, 4 and 2, then there are no elements left to compare with 2. So 2, okay, so now, and also we can see that 2 had come to the zeroth index now, because we will do a j minus minus, and j will be the index of the key, right? So 2 is already at zeroth index. So now what we'll do, we'll end that operation and just place our 2 there. Place our 2 at wherever our j has been finalized, or j has stopped iterating. So just place that 2 here, and that's it. As you can see, for now our array is also sorted. Not sorted, but if we consider only the two elements, then the array is sorted. 2 and 4, the array is sorted. First of all, our array was sorted till here when we considered only one element 4. Now when we consider two elements, now our array is sorted till here. Okay. Now going to the next index, that is number 3. Now we are considering 3 as our key. So let's again compare. Is 3 smaller than 4? No. Is 3 smaller than 2? As you can see, now 3 is indeed smaller than 2. Now what do we need to do for that? Okay, I performed a mistake. Actually, 3 is smaller than 4, right? I have made here a mistake. 3 is smaller than 4. Yes, 3 is smaller than 4. So again, we need to perform that right shift of the whole array until and unless we find an index element or an element that is smaller than 2. So first we will perform the right shift. That will be 4 will come here. 4 will be right shifted. And again, we will compare with 2. Is 3 smaller than 2? No, condition is false. Once the condition is false, the loop will be stopped. And at that particular index of j, our key will be placed. That particular index of j, our key will be placed. And where our j has been stopped. If you remember that our j has stopped right here. Sorry, yes, our j has stopped right here because it was greater than 2, so j has stopped right here. Okay, so as I told that wherever the j stops, we need to put our key there. So here, our key will be put instead of 4. And up till here, our array is sorted. Right now, up till here, our array has been sorted. And after completion of the operation, okay, now going on to the next index and considering the next key. So now the next key is -1. So now let's see what happens. Okay, now is -1 smaller than 4? Yes, indeed, -1 is smaller than 4. So left shift 4, 2, 3, 4, 4, 6, 0. Is -1 less than 3? Yes, indeed, -1 is less than 3. So now what we need to do, we need to left shift 3 as well. Until we come up our array is something like this: 33460. Sorry, right shift, right shift. When we are performing the shift right side, always right side shift. Okay, and then is 2 less than -1? Oh, sorry, is -1 less than 2? Yes, key is smaller than the next element, so we will again perform the shift. We will perform right shift of 2 now. Which 2 has been put on the right place. Means here 3 has been removed to his index, and then 2 has been removed to his right shift. Only we are performing this right shift, nothing else. Until and unless we are getting an element that is smaller than -1. Since there are no element that's -1, smaller than -1, and the key has already reached the 0th index. The -1 has already reached the 0th index, so the loop will stop here, or the process will stop here, and we will just simply place uh, our key at that element, at that particular index. And here our index is now 0. So placing -1 at its rightful position, and our array is sorted up till here now, where the key has last been. Now the key is moving to the next index, that is number 6, and we need to check 6 for all the elements. Okay, now is 6 smaller than 4? No. And here there is one advantage: if there is any element, if the left side element of our key is smaller, if the left side element of our key is smaller already, then we don't need to perform any further operation. Okay, we don't need to perform any further operation if the left side element of key is smaller, then we don't need to perform any shift, because it is already sorted, right? If 6 is greater than 4 and our previous means the left side array is sorted, then the 6 is already present in its correct position. Okay, now moving on to the next index. Now key is present here, key is now at 0 now, and for the that part, our array is sorted up till here now. Our array is sorted up till here, and key has moved to last index. Okay, now we again need to perform the checks, so we'll perform them. Is 0 smaller than 6? Yes, 0 is smaller than 6, so we need to right shift 6 by one position, and we will do that. 066. Is 0 smaller than 4? Yes, indeed, so we need to move 4 by one index, right shift 4 by one index. Is 0 smaller than 3? Yes, indeed, again, so we need to shift 3 by towards the right side by one index again. Now is the 0 smaller than 2? Yes, indeed, so we now need to perform right shift on number 2, the second element. And now here is the catch: is 0 left less than -1? No, false. -1 is smaller than 0. So when the condition is false, what we need to do is just we need to replace it with the in replace our key here. Replace our key right at this index, at this position, at this particular index. We need to replace, or we can say we need to replace our key right before this index plus 1. Before this index plus 1. Either we need to replace our key at here at this position, or we can replace our key at this index plus 1. Both will give us the same answer only. And here also, when I told you that we don't need to check for 6, why? Because if we perform this check on 6, then what will happen? 6 will get replaced in its own position only, because the k is here and j is also pointing here only, because 4, because suppose if this is j, consider that this is j, right? If this is j, then see that 4 is already smaller than 6, so j plus 1, right? J plus 1 will be replaced by the key, or j plus 1 will be replaced by the key. So when that happens, the key will be present in its position only, so no need to perform the swap. Okay, it will get more clear once I give you the code explanation, once I write the code. But for now, let's understand with this example, following example only. So now since -1 is greater than 0, -1 is greater than -1 is smaller than 0, so we don't need to perform any right shift again, and we will place the key in its correct position, that is right here, because our indexing has stopped right here, our process has stopped right here before coming to -1. So doing it that 0 2 3 4 6, and our whole array is sorted. Now our array is sorted up till here, and that is the end of the array. And once the array is ending, we will also end our for loops, and our complete array got sorted, as you can see. Now I will give you the code as well. I will write the code in front of you, and hopefully you will be able to understand what is happening. So let's just write a function. Let's just name it insertion. Okay, just name it insertion short. 1 minute. Also, the code will be present in the description of this video as well. And if you have any doubts, you can also comment in this video, and I will try to reply it as well. Then where you can consider this in as the size of the array. Okay, consider n as the size of the array, and we are also taking our array in the insertion sort. Now, I will start out for loop for int I is equal to 1. Why 1? Because as I have told you earlier, that whenever there is only first element in the array, the key is first, then it is already sorted because there is only one element, which is 4. And once there is only one element, only 4, then it is already sorted. So we are checking from the second element. We are starting to check from our second element. Considering the key from the second element. Considering the key to the second element. Okay, I is less than n, the size, and I plus plus. Okay, inside this for loop, what we will check? We will first store our key. Int key is equal to ARR of I, right? And with whom we will compare? We will compare our key. We will compare our key with an index j. And what will be the j? J will be nothing but I minus 1 index. Now, why I minus 1? Because as you can remember what I told you, that we need to check with the left side elements, right? So if this is the key, then j is equal to key k minus 1 index. K minus 1 index, right? Here k is the index, but here when I have written key I am taking as the element only. Okay. Okay. I hope you have got it clear. All right. Now, inside will be our the main process, whatever will be happening. For that, we will be writing a while for performing the shift. As you know that we need to perform the shift operation. That 6 will go to its right position, 4 will go towards right, 3 is going towards right, and 2 will be going towards right position. All this shift will be performed inside the while loop. Okay, all the shifting will be happening inside the while loop, and I'm showing you the logic how to do that. First of all, we will check for a condition that if our j is greater than or equal to 0 or not. If it is, if our j is greater than or equal to 0, then we will stop the array there and there only. As I have told you the condition, if at any given condition, either the key is smaller than the element, or it has reached 0, it has reached the first index, then we will stop and we will place our key there only, right? So if our j is greater than or equal to 0, that means it has already got into the first position of the array. So no need to perform any shift because there are no more elements left, right? And one more condition, what was that? If our ARRJ, that is the previous element of the key, is smaller than the key, right? If ARRJ is greater than the key, sorry, if ARRJ means if the previous element of the key is greater than the key, then also we don't need to perform the shift, right? Because the key is already present in its correct position, as I have told you earlier. If the key is already here, consider this place. If the key that is here, the key was 6, and if 4, the previous element, is already greater than the key. Sorry, if it is smaller than the key. If it is smaller than the key, then we don't need to perform any operation, and we will stop our loop while loop right there and just place our 6 in this correct position that is there only. Okay, but here, as you see, if our key is smaller than ARRG, then we need to perform the what do you say? We need to perform the shift operation. So it will come within our while loop, and what we need to do? We need to perform the shift operation, and we will perform shift. We will just shift the left side elements one position towards the right. We will shift all the left side element one position towards the right until and unless we get a element that is smaller than the key. I hope you understand. And here I will just do j minus minus. It is basically j index will be getting reduced after one shift is performed. The 6 is gone to its right side. Then j will come here. Then after 4 has gone, then j will come here, and that's our loop will be going on continuing. That's how our loop will continue to go on. Okay, I hope you are getting it. Now, after this operation has been done, if there is no more elements left to be checked, that is already j has reached -1. Right? If j has reached -1, that means there are no more elements left, or you can say that the key is already has reached the 0th index, or it has gone to -1 index. Or if the element is larger than the key, sorry, if the element is smaller than the key, both in those cases we will stop this loop, and we will what we will do, as I told you, that we will place the key in its correct position. We will place the key in its correct position, and just that's it, and our whole program is being done. We'll close our for loop and we'll close our function, and this is the gist of it. This is our function how insertion sort works, and it will be working absolutely fine. Once you write, you can also practice in the lead code. I will also try to share a link, practice code link in the description as well. Okay, so this is how it is going, and as I have shown you here also, I suppose, yeah, see, I have also told you that at j plus 1 index our k needs to be placed at the rightful position. We need to place our key. So that's it, guys. This and one more thing, the time complexity. So as you can see, we are using a while loop within another for loop. So in cases of worst time complexity, in worst case, time complexity in worst case, it will be big O of n square. Time complexity in worst case, it will be big O of n square. Why? Because assume that our whole array is let's say our whole array is in descending order, and we will try to sort it in ascending order. In that case, since it is a worst case, here the time complexity will be n square, and the average case time complexity is also big O of n square, because we still need to perform the j is, or whether it is smaller than the key or not, or the key is smaller than its previous element or not, and accordingly we need to perform the right shift on all the other elements. We What we are doing here, basically we are taking the key and comparing our key with all the left side elements. Now if the left side elements are smaller, then sorry, if the left side elements are larger, then we are performing right shift on the left side elements. I hope you got it clear. And in the best case it is big of one, just because it will not come into the loop only. Means it will only go through this sorry, not big of one, it will be big of n time complexity, because it will not come under this while loop. Every time the while loop will be false if the array is already sorted in ascending order. If the array is already sorted in ascending order and we are trying to make it sort in ascending order only, then this while loop will never be done, and it will just give us a big of n time complexity. Okay, so that's it, guys. And for the space complexity, for space complexity, it will be big of one only, because we can perform what to say, we can perform the shift operation on the given array only. We don't need to take any other array and place it down, and put the array into another vector, or put the array into another array and then perform the shift operation, and then we need to check compare our both the arrays. There is no such trick. We can perform the same operation in the given array only. So the instead apart from the given array, there is no extra space complexity being required, so it is big of one. That's it, guys. That's it for the video. That's it for the lecture, and hope to see you for the next one. We will bring another amazing video on another amazing topic. If you appreciate our work, please do consider subscribing to our channel, and please hit on that like button and click on the bell icon, so that you will never miss a notification from our end. Thank you, guys.
But it's no use, 'cause you can't stop it from shining through. It's